Welcome to 9.3, where we're going to learn 5 double angle formulas, 3 half angle formulas, and 3 reduction formulas. But let's start with the good news. Literally none of those formulas are anything new, and I know I say this all the time. They all come exactly from 9.2. Every single one of those, I can't count. You count it for me. All right. Every single one of those many formulas is actually just going to be something that we did in 9.2. So new formulas, we'll use them in pretty much the same way, just more practice for all of you here. And a lot of added things in the formula sheet. We're going to start with example 1, where we're going to derive the first one. Derive the formula for sine of 2 theta using sine of theta plus theta. So double angle formula is just, well, it's going to be, what is this equal to? If we have double an angle on the inside, how does that behave? Well, remember that 1 theta plus another theta, well, now we just have 2 thetas. So this comes directly from the angle sum formula that we did in 9.2. So angle sum said it's going to be the sine of the first angle times the cosine of the second angle, plus, for cosine they're opposites, for sine they are the same, plus the cosine of the first angle times the sine of the second angle. Well, the first angle and the second angle are the same, and multiplication is commutative. A times B is the same as B times A. So sine theta cosine theta is the same as cosine theta sine theta. These are both the same thing. We have 2 that we're adding together. We say we have 2 of them. There you go. That's the double angle formula for sine. You could do the same thing with cosine. You could do the same thing as tangent. So here we go. Sine of 2 theta is this. And let's actually put this all on the next page so it's all kind of together and we can make this look a little nicer. Cosine of 2 theta, there's actually 3 that we're going to use. 3 double angle formulas all for cosine. So we can do the same thing that we did before to prove that this is one of the formulas for the double angle for cosine. And then we can use Pythagorean identity to give us 2 other forms. Right, sine squared plus cosine squared of any angle is equal to 1. So you can move things around and substitute out the cosine squared and do some simplification. That's going to give you something that looks like this. And you could substitute out the sine squared as well and do some simplification. You could very easily do that on your own, or maybe not very easily, but you could do that on your own. We're not going to take the time here. And then again, tangent of 2 theta. Compare this tangent formula with, again, the angle sum formula for tangent in the last video. Again, you can see it much more clearly. You know, if we're adding 2 angles together, we just multiply their tangents, or sorry, we add their tangents, but their tangents are the same if the angles are the same. And then right here, we just multiply their tangents. So that's why we have a tangent squared, because again, the angles are the same here. So these are our double angle formulas. Every single one of them comes from the angle sum formulas from 9.2. We use Pythagorean identities to get these 2. Okay? And that's where we're at. That's where this video is going to be. We'll use this, get some practice, and then talk about the other 2 formulas that are, again, the other 2 formulas that we're really doing in this section are still all these guys, just in disguise. This is like this is like one of those cheesy movies where they just wear all these silly disguises. All of these formulas are the same person in disguise. I take off my glasses and I'm a superhero. That's basically what's happening here. All right, let's move on. Let's use some of these. Let's get some practice. Example 2. Given that tangent of theta is equal to -3/4 and theta is in quadrant 2, find the following. Part A, find what the sine of double that angle is. All this is just using the formula and then using chapter 7. Okay? So the formula, what is sine of 2 theta? There's only one choice here. 2 sine theta cosine theta. And then we have to find out what sine and cosine are. Now be very careful here. I make a big deal about how tangent of any angle is the sine of that angle divided by the cosine of that angle. So you might be tempted to say, oh, sine is -3 and cosine is 4. But no, this is the reduced ratio of sine over cosine, but this doesn't tell us what sine and cosine are directly. Specifically, sine of theta can't be -3. Sine has to always be between -1 and 1. All right, so watch out for that. We're going to need a picture. So go off to the side. We're somewhere in quadrant 2. Theta is going to be this guy. And the tangent is -3 over 4 opposite over adjacent. Oh, so right off the bat, right? I know that this is wrong. This is what I was thinking earlier. We're in the second quadrant, right? So the negative has to go over here. The x coordinate has to be negative. And again, there's a couple of ways of thinking about negatives when you're doing this. We can use what we know about Pythagorean theorem or special triangles. This is a 3, 4, 5 triangle. So the sine should be positive. It's in the second quadrant. Sine of theta is just 3/5 opposite over adjacent hypotenuse. Cosine is -4/5. So we just need to do some simplifying now. And we should get -24 over 25. That is what sine of 2 theta is. You might say, Jason, you said sine in the second quadrant is positive. And theta is in quadrant 2. What's the deal? Sine's negative here. Well, theta's in the second quadrant, but that doesn't mean 2 theta's in the second quadrant. So 2 theta could be in the third quadrant, or it could be in the fourth quadrant. And both of those, sine is negative, so it does make sense so far. Cosine of 2 theta. So this one, we need to use a double angle formula. And we've got 3 choices. All of them are okay. A lot of times I prefer one of the later 2, the second or the third, because it's just fewer things to plug in. But sometimes the first one can be nicer as well. So choose, do all 3. Hopefully you get the same answer. So pause the video right now and try to use one of these formulas and see that we get the same answer. All right, then I'm using this formula. 1 minus 2. What is sine of theta? Well, we already found sine of theta to be 3/5. Now we have to square it. To get 1 minus 2 of 9 over 25. We'll have to simplify this. Get a common denominator. 1 becomes 25 over 25 minus 18 over 25. And we should get 7 over 25 as the cosine of 2 theta. So I mentioned that 2 theta, this angle, 2 theta, double the angle theta. Theta is in quadrant 2. I mentioned that this angle 2 theta has to either be in the third quadrant or the fourth quadrant. And now we know. Is it in the third quadrant or the fourth quadrant? It has to be in the fourth quadrant because cosine's positive. Can't be in the third quadrant. Cosine's negative in the third quadrant. So we do know that 2 theta is in the fourth quadrant now. All right, and tangent, again, tangent is just sine over cosine. But let's get some practice. We'll check our answer, make sure it's sine over cosine. Tangent of 2 theta is equal to, I believe, 2 tangent of theta divided by 1 minus tangent squared of theta. I believe that's our formula. And what is the tangent of theta? It tells us it's -3/4. 2 times -3/4 divided by 1 minus negative 3/4 squared. Let's simplify a little bit and then multiply by the LCD. This becomes negative 3/2 on the top over 1 minus. Be very careful. We think, oh, subtract a negative, but we have to square it first. When it squares it, it becomes positive. 1 minus 9/16. And now we can simplify by multiplying by the LCD, 16/16. On the top, this cancels. And we get negative 3 times 8 is negative 24. On the bottom, we have to distribute. First one becomes 16. Second one, the 16s cancel, and we get 9. Should get negative 24 over 7. And maybe I'm right. Maybe I'm wrong. Maybe I made a mistake on purpose. Probably not. If I made a mistake, it's on accident. Let's check our answers. Right? It should also be sine of 2 theta divided by cosine of 2 theta. Tangent of any angle is the sine of that angle divided by the cosine of that angle. And sine, we said, was negative 24 over 25. Cosine, we said, was 7 over 25. The 25s cancel. And we get negative 24 over 7. Oh, great. The formula worked. These should always be the same. All right. That's the double angle formula. Let's do one more example to tie it all together, and then we'll move on. Most of the section is about at this level. The half angle formulas can sometimes trip people up, but I don't think they're inherently awful. But there's 1 or 2 reasons where they can maybe trick you up. But the rest of the section should be about like this. Whether that's good or bad, I don't know. Write the cosine of 6x in terms of cosine of 3x. So the wording of this question might look a little weird, but this is something that's very, very useful in specifically Calc 2, okay? When we're doing integrals, when we're finding antiderivatives, when we're trying to undo derivatives in calculus. Being able to, this whole section actually is big in Calc 2, being able to change the inside of cosines and then change the powers as well when we get to that reduction formula. Something very nice when we're doing integration. So, but anyway, for here, we're just going to get some practice for something that you're not going to do for a couple more classes, or maybe you're never going to get to integration. Who knows? I don't know how far all of you have to go in mathematics, but for those of you who do know that you need calculus, zoom in on this one. So the important thing to note here is if 3x is some angle, we can call that angle whatever we want, then 6x is just double that angle. So if you want, you can just make a substitution. Just call 6x 2 theta, call 3x theta, or you can do it in a couple different ways. It's kind of just there's a bunch of different ways to approach this problem, but the important thing is that you recognize that 6x is just double 3x, and we can use double angle formula. So there are 3 options for cosine. Cosine squared minus sine squared, 1 minus 2 sine squared, and 2 cosine squared minus 1. And normally we have free license to choose any of these that we want, but not in this problem. Why? Because it tells us. It wants it in terms of cosine. So this problem is specifying this doesn't work because this has a sine. This doesn't work. This has a sine. This does work. So we're going to use that one. I'm going to copy the formula down. Cosine of 2 theta is equal to 2 cosine theta minus 1. Wait, I always get these mixed up. So again, if theta is 6x, if 2 theta is 6x and theta is 3x, then this just gives us that the cosine of 6x is double the cosine of 3x squared minus 1. And we've done exactly what the problem asked us to do. right? It doesn't matter what these are. What matters is that the thing on the left is double the thing on the right. There you go. A little prep for calculus. And that's the end of this video. And then we'll do some identities videos, some reductions, and then the half angle formula is the last one before I do homework problems. And that's the one that can be a little tricky, but it's not too bad, I don't think. Trust me. I've never steered you wrong, right? I've never said something is easy. That sometimes I do that. No, it's not easy, but you can survive it. We'll do it together. Good luck. Bye-bye.